All right, today's video is on factoring binomials, which is difference of squares and cubes. And actually we have sum of cubes too. But the key is these are binomials, which means they have two terms. It's a way to recognize to use this kind of thing. So I'm going to start with difference of squares. And the formula for factoring difference of squares is if we have a squared minus b squared. So that's a difference, meaning there's subtraction. And that factors to a minus b and a plus b. And now if we FOILed this together, the reason that these signs need to be different is that the middle term is going to cancel out, so we're going to be left with just two terms. So if we go FOILing, a times a is a squared, then a times b is plus ab. Negative b times a is minus ab, and then the last would be minus b squared. So the plus ab and the minus ab cancel out, and we just get left with a squared minus b squared. So that's why it factors to that. So let's try an example of how to do this. And I'm going to do 9a squared minus 25b squared. First of all, we need to recognize this as a difference of squares. It's a difference, meaning subtraction, and that's very important, of two perfect squares. 9 is a perfect square, a squared is a perfect square, 25 is a perfect square, and b squared is a perfect square. So we want to identify what a and b are, and I think that's helpful, especially if the numbers get a little more complicated than this. And so I'm going to say, okay, a will equal the square root of 9a squared, which is going to be 3a, and b will be this term, which is going to be 5b, because that's the square root of 25b squared. So then we plug it into this formula. So this will factor into 3a minus 5b, and it could be plus or minus. All that matters is that they can change, that they're different, and then 3a plus 5b. So 3a minus b, 3a plus 5b, or it could be 3a plus 5b times 3a minus 5b. So that's how that factors. That's my first example. All right, so here's my second example. So this is two terms which could be factored as difference of squares and cubes. Now this is a difference, so that helps, but are these two perfect squares? And no, 8 is not a perfect square and 2 is not a perfect square. But remember, one of my tips and tricks from the earlier videos is that you always want to look for the greatest common factor to factor out first. So I'm going to notice these are both even numbers, so I can factor out a 2. So if I factor out a 2, what's left is 4x squared minus 1. Now, 4x squared is a perfect square, and 1 is a perfect square. It's kind of a sneaky perfect square, so you don't always recognize it. So I'm going to say a equals 2x, b equals 1. So I'm going to make sure to bring down that 2. I don't want to forget that. And it's going to be a minus b, a plus b. So it's going to be 2x minus 1 and 2x plus 1. So that's how that one is done. That's my second example. All right, this is my third example. Notice we have two terms. They are both perfect squares, but there's one major problem here, is in that it's not a difference. It is a sum of two perfect squares. So this cannot be factored. So when something can't be factored, we write prime. So those are my three examples for difference of squares. All right, now we're going to move on to the difference and sum of cubes. There can be a sum of cubes where there cannot be a sum of squares. There can be both. So I'm going to first write down the formula for the difference of cubes. And it'd be a cubed minus b cubed. That's the difference subtraction of cubes, two perfect cubes. And that formula is a minus b, and it's a squared plus ab plus b squared. And right underneath, I'm going to write the a cubed plus b cubed formula. We're going to talk about how to memorize these. And that's a plus b, a squared minus ab plus b squared. They're identical as far as the variables go. The only difference is the signs. And this is my tip and trick for this, is a way to remember how the signs go. If this is negative, if this is a minus, it matches it, it switches to plus, and it stays positive to plus. For positive, it matches, switches, and then turns positive. So my mantra for this is match, with a C there, switch, and plus. So match, switch, plus. So as an example, we're going to factor 8y cubed plus 27. Now 8 is a perfect cube and 27 is a perfect cube. What are perfect cubes? Sometimes I like to make a list so you can sort of know. But 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. You basically take the number by itself 3 times and get these. So just sort of keep these, keep those in mind. But anyway, so we're looking at this. This is going to be now a sum of 2 perfect cubes. So let's figure out what the formula is that we're going to use. And so that would be a cubed plus b cubed. So this would be match, which is a plus, switch, which is a minus, and then that's always a plus. So what I would do every time you do this problem is rewrite this formula down. Now, this is a more complicated program than more complicated formula than difference of squares. So I would write it down, and I would especially write down what a and b equal. So a, in this case, the cube root of 8 is 2, and the cube root of y is y, and b would equal the cube root of 27, which is 3. So now we have our formula written down, and we're just going to plug things directly in there. So it would be a plus b, or 2y plus 3, with the matching sign. Then we have, we have to be careful here. We have it's 2y, parentheses, squared, minus ab, which is 2y times 3. And I'm going to erase this so we have more room. And then it would be plus b squared, which is 3 squared. Now notice I put all of these in parentheses so I don't get mixed up. Now I need to simplify this. So it's going to be 2y plus 3. That's as far as we can go with his. 2y squared, be careful here. This squared applies to the 2 and to the y. So that's going to be 4y squared minus 2 times 3 is 6. So 6y plus 9. Now, even though this looks like it can be factored, this cannot be factored, this term. So don't try, don't waste your time. So be really careful with squaring these terms. Write them out carefully like this, and then be sure that you get both terms are squared. So our final answer for factoring 8y cubed plus 27, 2y plus 3 times 4y squared minus 6y plus 9, match, switch, plus. So I hope that helps.